Have you ever thought about riding on top of water? Or sailing at high speeds on a solid sheet of water? Have you ever thought about cruising on top of water? Or stretching water? Or seeing water vanish into thin air? Or cutting water? All these things are possible, and all depend on the phases of water. During the next few minutes, we are going to discuss some of the characteristics of water, as well as other materials, and look at why a single substance like water exists in so many different forms. We will also explore the 4 states of matter: solid, liquid, gas, and plasma. Water can exist as a liquid or as a solid in the form of ice. Solids have 2 important characteristics. Solids, like this ball, have a definite shape. Second, solids have a definite volume. In other words, they take up a definite amount of space. Matter, like this brick, is made of tiny particles. The particles move or vibrate slowly. This is how a solid maintains its well-defined shape. In solids, the particles are packed tightly together to create a definite shape. Most solids are made of particles that have a definite regular pattern called a crystal. Snowflakes are a solid made of crystals of water. This is a single 6-sided snowflake. No 2 snowflake crystals are exactly the same. Liquids, like the water rushing in the stream, have no definite shape. Liquids, such as this fruit juice, take on the shape of their container. And liquids, like milk, spread flat across a surface when they are spilled. While liquids do not have a definite shape, they do have a definite volume that can be measured with flasks or graduated cylinders. No matter how the shape of the container changes, this liquid still has 1 liter of volume. The particles in water are freer in liquids and move around more than in a solid. Some liquids have greater resistance to flow than others. This is called viscosity. Maple syrup has a high viscosity and flows very slowly. Maple syrup is derived from sap that comes from maple trees. The sap drips out of small holes placed in the tree. The sap has a low viscosity and drips into buckets like these. Inside small buildings like this one, the sap is boiled for long periods of time. Eventually, the sap turns into a syrup that is sweet and has a high viscosity. It is easy to see the elastic nature of syrup, but water also demonstrates a certain degree of elasticity, a property that implies stretchiness, as seen here. Water can also be a gas, as seen here in the form of steam. Gas is another phase of matter. Gases do not have a definite shape or a definite volume. Quite often, you cannot see gases in the air. However, a vapor can sometimes be seen coming off of water, as in this hot cup of tea, or as other gases seen here rushing out of this valve. And sometimes, even though gas cannot be seen, it can have an odor, as with the case of this natural gas on this stove. Because gases do not have a definite shape or volume, they can be compressed, or they can expand. Gas can be pumped to fill a small volume, as is the case with this balloon. Or gas can spread out to fill a large volume, like the water vapor gas filling the air. The fast-moving gas particles in this hot air balloon are more scattered than those in solids or liquids. All of this particle motion causes gases to expand, creating outward pressure. This machine is a gas compressor that squeezes gas into a small volume. The gas is put under such great pressure that it can be used to hammer nails into this piece of wood with tremendous force and speed. This balloon is filled with gas that is pressing against the walls of the balloon. When you squeeze the balloon, it gets harder and pushes back against your hand. By pushing on the balloon, the volume decreases, but the pressure increases. This relationship between volume and pressure is called Boyle's law. Boyle's law states that a volume varies inversely with pressure. Another example of Boyle's law is demonstrated with this canister and this antacid pill. When placed in the canister with a small amount of water, the pill reacts with the water, producing a great deal of gas. The pressure built up by the gas exceeds the strength of the lid and causes it to blow off. Charles's law also describes the behavior of gases. It states that there is a direct relationship between temperature and volume. Let's see how Charles's law works. This balloon has a circumference of 60 centimeters. The temperature in this freezer is well below freezing. Let's place the balloon in the freezer for a few minutes. What do you think will happen? After being in the freezer for several minutes, we will investigate the change in volume. As you can see, the balloon's circumference decreased to 56 centimeters. This means that volume decreases with a decrease in temperature. Let's see what will happen to the balloon with a circumference of 60 centimeters when it is heated. This oven has a temperature of over 80 degrees centigrade. What do you think will happen to the balloon if we put it in the oven for several minutes? After several minutes in the oven, the balloon is taken out and then measured. You can see it has a circumference of 66 centimeters. Here, an increase in temperature caused an increase in volume. Plasma is the fourth phase of matter. Plasma is quite rare on Earth, but it is quite common in the universe. Our Sun, for example, contains plasma. This close-up of the Sun illustrates the movement of plasma. Matter in the plasma phase is extremely high in energy. In stars, like the Sun, gas particles break down at temperatures of over 1 million degrees centigrade to form plasma. And believe it or not, plasma exists in common household fluorescent lights. This occurs when an electric current converts mercury to plasma. What makes a substance like water able to exist in three phases: solid, liquid, and gas? And what causes water to change phases? The key is energy. Liquids contain more energy than solids, and gases contain still more energy than liquids. By taking away or adding energy to matter, a phase change can occur. A phase change is matter changing its state or phase. For example, water is used to make ice cubes. The water is placed in the freezer where energy is taken from the water. If enough energy is taken from the water, then a phase change occurs from liquid to solid. In other words, water becomes ice. Melting, vaporization, condensation, freezing, and sublimation are all phase changes of matter. When a substance changes from a solid to a liquid, melting occurs. Melting is the changing of a solid to a liquid. For example, when heat is added to frozen ice cream, it changes to a liquid. The melting occurs when matter absorbs heat. The melting point is the temperature at which a solid changes to a liquid. Different types of matter have different melting points. Solder, a substance used to join metals together, such as pipes, has a melting point of over 230 degrees centigrade, whereas water or ice has a melting point of 0 degrees centigrade. This beaker of ice has a temperature of just below 0 degrees centigrade. This Bunsen burner is used to apply heat. The temperature rises to 0 and the ice begins to melt. After several minutes, all the ice melts to water. What do you think will happen if the water is heated more? As more heat is added, the temperature continues to rise. Here, the temperature is 90 degrees centigrade. The temperature eventually reaches 100 degrees centigrade. At this temperature, vaporization occurs. Vaporization is the process of a liquid changing to a gas. Notice the steam coming off the surface and the bubbles rising from the bottom of the beaker. This is called boiling. Boiling is the process of a liquid changing to a gas at its boiling point. The boiling point of water is 100 degrees centigrade. In this process, particles absorb enough heat to change the liquid to the gaseous phase. Evaporation is vaporization that occurs at the surface of liquids. This is a slower process than boiling. Here, particles of a liquid slowly change to the gaseous state at the surface. By retracing the temperature curve of our beaker of ice, we see that as water was heated, the temperature of the ice rose to 0 degrees. At this temperature, melting occurred. When all the ice melted, the temperature of the liquid rose to 100 degrees, where boiling began to occur and where water changed to water vapor. When heat is taken away from matter, a series of other phase changes occur. Condensation occurs when heat energy is taken away from a gas and it changes to a liquid. Notice the water on the outside of the cold glass that condensed from the surrounding water vapor in the air. This process also occurs in clouds. Here, water vapor cools to form tiny droplets of water. As liquids cool, their particles slow down, and they may become solids that can even be cut, like this ice. Freezing is the process of a liquid changing to a solid, enabling boats like these to skate across frozen lakes. The temperature at which a liquid becomes a solid is its freezing point, and water's freezing point is 0 degrees. It is possible for some substances to go from the solid to the gaseous phase. This is called sublimation. This dry ice goes through the sublimation process as it changes directly from a solid to a gas and does not pass through the liquid phase. Next time you boil some water to cook some food or put ice cubes in your glass of juice, think about the different phases of matter. The phases of matter, solid, liquid, gas, and plasma, have a big effect on our daily lives, and it shapes the world in which we live. So the next time you get a chance, try to identify some of the phases of matter in your surroundings. Think about how the changes occur. You may just be surprised at what you learn. Fill in the blank with the correct word when you hear this tone. Good luck, and let's get started. Number 1. Solids have a definite shape and definite. Number 2. Liquids have no definite. Number 3. Is the measure of a liquid's resistance to flow. Number 4. Boyle's law describes the relationship between volume and Number 5. The relationship between volume and temperature is described in law. Number 6. The sun and other stars are made of a type of matter called Number 7. When matter changes from a solid to a liquid occurs. Number 8. Occurs when a gas changes to a liquid. Number 9. Water freezes at degrees centigrade. Number 10. Is the driving force that causes matter to change phase.